Hi, in this lesson we are going to look at two simple programs, and these programs will illustrate the concept of nested loops. Till now we have seen simple loops, but in this program we are going to nest the loops. Let's see the first example where we are going to print mathematical tables. We are printing first 10 tables. So here you can see first table, second table, third mathematical table for 4, 5, 6, 7, 8, 9 and 10. So in each table we are printing 10 rows, right? This is a 10th table, and in this 10th table I am printing 10 rows. So what we have to do is first we have to iterate from 1 to 10. When I am in the first iteration with a value of 1, I have to write a nested loop so that I can iterate 10 more times to print the table. Okay, let's see that in code. In code it is going to be very simple. So this is the first loop. Okay, so here in this loop we are going to have 10 iterations. So from 1 to 10. So when I am in this loop for the first time, the value of I is 1. So using that value, what I can do is I can iterate 10 more times with value of 1 and print I into j. So for the first iteration where I equal to 1, j is varying from 1 to 10. So every time I am going to print I, j and I into j. So this is going to print the first table. Let's limit ourselves to one table. So I am changing the I value from 1 to 1. So it is going to be only one iteration. So and I value will be 1. If we come here, j value will be going to be 1 to 10. So this is going to be iterated 10 times. Every time I value is going to be 1 only, right? Because I started with 1 and I is going to end with 1. So for the first iteration I value is 1 and j value will vary from 1 to 10. So 1 into 1, 1, 1, 2 into 1, 3 into 1, 4 into 1. That's how it's going to print. Only one table because I is varying from 1 to 1 only. Okay, let's see the output. So here we have seen that, right? Now let's increase the value of I to 2. Okay, so for the first iteration I is going to be 1. For the second iteration I is going to be 2. When I is 1 we are printing first table. When I is 2 we are printing second table. Let's see the output. So by changing the value we can print whatever number of tables we want. Okay, if we want to change the number of rows in each table, we can change the value of j. Let me limit it to 2. Okay. So here you are seeing 10 tables, but in each table you are seeing only 2 rows. I can change it to 20 as well. So in each table you are seeing 20 rows. So outer loop is controlling the number of tables and inner loop is controlling the number of rows in each table. So you can make some small changes to this program. I made some changes to this program and I executed. So I believe the concept is very clear to you. But make sure whenever you are writing these kind of programs, nested loops, the values are proper. For example, here in this loop you are controlling only value of I. So here it should be I. So here you are controlling only the value of j. So j. By mistake, if you increase the value of I here, let's see what happens. You are going to see some weird outputs. So I'm going to run it again. Okay. And this program is not terminating at all, right? So that is what happens if you mess up with these variables. So please be careful and extra cautious whenever you are writing nested loops. Okay, that's all about this first program where we are printing first 10 math tables. Let's move on to the second program. Here in this program we are going to print the prime numbers between 1 and 100. So 1 is not prime because prime number has to be greater than 1. So I am printing that. 2 is prime, I know that, and because it is the only even prime number. So for all other numbers from 3 to 100, if you see from 3 to 100, I am going to iterate and check whether the value of whether the I is prime or not. Okay, I'm pasting it back. Okay, so for the first iteration I is going to be 3, and I am assuming 3 is a prime number. Then in the loop I am checking whether it has any divisors or not. That is what we have previously seen in our prime program. So I am using the same logic. I am assuming it is a prime. Then I am checking whether it has any divisors. If it has any divisors, then I am saying is prime equal to false. At the end I am printing that whether I is prime or not. So this loop will get executed from I equal to 3 to I equal to 100, and every time at the beginning I assume that number is prime, then I will iterate. So this is the inner loop here. Inner loop is controlled by J, and in the inner loop I am checking whether I has any divisors or not. Okay, so I assume that I is prime, then I will check whether that is has any divisors or not, then I will print the message. Okay, that is all about this program. This is very simple one actually, because we already know the logic for checking the prime numbers. Let's execute this. Okay, here you can see the first 2 messages I have printed. After that I am checking from 3 to 100. 3 is prime, 4 is not prime, 5 is prime, 7 is prime, 11 is prime, 13 prime, 17, 19. So if you see this output, this is what we wanted, but this is very difficult to read, right? There are only few prime numbers, but we are printing every number whether that is prime or not. So instead of printing this, what we can do is simply we can check if it is prime, then only print that number. So if I is prime, I'm going to print it, otherwise I don't print it. So let's execute this again. So these are the first 2 messages we have printed. After that we are going to see all the prime numbers. Okay, so you can go through this program. To understand, you can first cut this, so you will understand that we are checking for I from 3 to 100. So we are checking whether the numbers between 3 and 100 are prime or not. Inside this, whatever we have written, that is taken from the prime program only. So it is going to be easy. Please go through this program, try to understand it. If you have any questions, please post them in comments. Thank you for watching. Please subscribe and share it with others.